हामी रिलेसनशिप बिट्विन कन्टिन्युटी एन्ड डिफरेन्सिएबिलिटीको बारेमा कुरा गर्छौँ. इफ अ फङ्सन इज कन्टिन्युअस देन इट इज डिफरेन्सिएबल. यदि कुनै एउटा फङ्सन चाहिँ कन्टिन्युअस भयो भने त्यो फङ्सनलाई डिफरेन्सिएट पनि गर्न मिल्छ. कन्टिन्युअस फङ्सन क्यान बी डिफरेन्सिएट. कन्टिन्युअस फङ्सनलाई चाहिँ डिफरेन्सिएट गर्न मिल्छ. फर इक्जाम्पल कस्तो भने लेट fx equals to x square plus 1 and x belongs to minus 1 comma 1. This function is continuous at x belongs to minus 1 comma 1. minus 1 comma 1 को बीचमा यो फंक्सन के हुन्छ कन्टिन्युअस हुन्छ भनेपछि यसलाई हामी डेरिभेटिभ पनि गर्न मिल्छ डिफरेन्शिएट पनि गर्न मिल्छ. फर एक्जाम्पल if limit x tends to कुनै एउटा भ्यालु हालौँ -1 र 1 को बीचको. So limit x tends to 0.5. It comes 0.5 square plus 1 equals to 0.25 plus 1 equals to 1.05. -1 र 1 को बीचमा हामीले यो भ्यालु हाल्यौँ भने यसको भ्यालु चाहिँ 1.25 आयो. यो चाहिँ फंक्सन कन्टिन्युअस भयो एट द पोइन्ट 1.25. सो इट क्यान बी डिफरेन्सिएबल अल्सो. यसलाई हामी डिफरेन्शिएट पनि गर्न सक्छौँ. फंक्सन इज कन्टिन्युअस देन it can be differentiable as well. That is the meaning of that is the relationship between continuity and differentiability. We'll go in derivative of hyperbolic function. Now we'll go in derivative of hyperbolic function. Derivative of hyperbolic function. At first, hyperbolic function is denoted by sin hx. Sin hx means it is the hyperbolic function in sine. Hyperbolic function of sin h. Sin hx, the value of sin hx is e to the power x minus e to the power minus x by 2. This is the value of hyperbolic function of sin hx. Second, the value of second hyperbolic function is cos hx. Cos hx is e to the power x plus e to the power minus x by 2. Now we move in tan hx. The value of hyperbolic function tan hx is e to the power x minus e to the power minus x by e to the power x plus e to the power minus x. Tan means sin by cos. So sin hx by cos hx is this. Sin hx means e to the power x minus e to the power minus x by 2. Cos hx means e to the power x plus e to the power minus x by 2. And sin by cos, this 2 and 2 are cancelled. So the remaining is e to the power x minus e to the power minus x by e to the power x plus e to the power minus x. These are the hyperbolic functions, sin hx, cos hx and tan hx. Now, we move in derivative of hyperbolic function. First, derivative of sin hx with respect to x. Derivative of sin hx is cos hx. Second, derivative of cos hx with respect to x. Derivative of cos hx is sin hx. Hyperbolic function of sin hx. Third, derivative of tan hx. Derivative of tan hx is sec h square x. Fourth, derivative of cot hx. Derivative of cot hx is minus cosec h square x. Fifth, derivative of sec hx. Derivative of sec hx is minus sec hx into tan hx. derivative of cosec hx, derivative of cosec hx is minus cosec hx into cot hx. Derivative of sine, cos and tan in hyperbolic function is positive, all are positive. Sin hx को derivative चाहिँ cos hx हुन्छ, cos hx को derivative sin hx, tan hx को derivative sec h square x, अनि cot sec र cosec को derivative चाहिँ सबै minus. Cot hx को derivative with respect to x minus cosec h square x, sec hx को derivative with respect to x minus sec hx into tan hx, cosec hx को derivative with respect to x minus cosec hx into cot hx. These are the derivative of hyperbolic function. Derivative of inverse hyperbolic function. Derivative of inverse hyperbolic function. Derivative of inverse hyperbolic function. First, derivative of sin h inverse x with respect to x. Derivative of sin h inverse x is 1 by 1 plus x square whole over root. Derivative of sin h inverse x is, with respect to x, is 1 by 1 plus x square whole over root. Second, derivative of cos h inverse x with respect to x. Derivative of cos h inverse x is 1 by x square minus 1 whole over root. Derivative of cos h inverse x with respect to x is 1 by whole over root x square minus 1. And third, derivative of tan h inverse x with respect to x is 1 by 1 minus x square. These are the derivative of inverse trigonometric function. Now we move in the relationship between hyperbolic function. Relationship between hyperbolic function. Relationship between hyperbolic function. First relation is cos h square x minus sin h square x is equals to 1. Cos h square x minus sin h square x equals to 1. This is the relationship between hyperbolic function cos and sine. Cos h square x minus sin h square x equals to 1. And what we get here is cos h square x equals to 1 plus sin h square x, and sin h square x equals to cos h square x minus 1. Sin h square x equals to cos h square x minus 1. Cos h square x minus sin h square x equals to 1, and cos h square x equals to 1 plus sin h square x, and sin h square x equals to cos h square x minus 1. Second relationship is second number, cos h square x plus sin h square x equals to cos h 2x. Cos h square x plus sin h square x equals to cos h 2x. And third is 2 sin hx into cos hx equals to sin h 2x. And fourth is sin h x plus y equals to sin h x into cos h y plus cos h x into sin h y. These are the relationship between hyperbolic functions. And यदि यो अरु हाइपरबोलिक फंक्सनहरु जस्तो tan cot र sec को टर्ममा आयो भने हामी त्यो सबैलाई sin cos र tan को फर्ममा कन्भर्ट गरेर सल्भ गर्छौं. यदि हाम्रो कुनै अरु हाइपरबोलिक फंक्सनहरु tan cot cosec sec को फर्ममा आयो भने त्यसलाई हामी sin cos र tan हाइपरबोलिक फङ्सनमा कन्भर्ट गरेर हामी त्यसको सल्युसन गर्छौँ। दिज आर द रिलेसनसिप बिट्विन हाइपरबोलिक फङ्सन्स एन्ड डेरिभेटिभ अफ हाइपरबोलिक फङ्सन्स।